Okay, so this recording is still on system of equations. We have done graphing solutions and we have done using substitution to find the solutions. This is more about setting up the system of equation, meaning we're going to create the equations from a word problem. So we've actually done this before. We've certainly done it with just one equation when we've had a word problem, but now we're going to do it with a system of equations, which means two equations, all right? So there will be two equations for the same exact word problem. And you'll see what I mean by that in a second when I do it. We will solve it out. In order to solve it, you will use either graphing or substitution. I'm going to use substitution. I'm probably not going to graph it. I might do both. We'll see. Mainly, though, that your grade is going to be based on creating the equation, so creating the two equations correctly. All right, so let's, I knew it wasn't going to work. So let's go to, here we go. So I am in Smartboard so that I can draw on it and show you how to solve the problem. Let me get rid of that. All right, so here's a system of equations. It's a word problem. Edwin goes to the game, to a baseball game, and he's going to buy some food for himself and for whoever he's with, his family, his buddies, whatever. So he decides to buy 3 hamburgers and 4 bags of fries. So his total cost is $31.50. So Selena is at the same game, same baseball game. So she goes, same vendor, buys 5 hamburgers, 2 bags of fries. So what they're asking are, what is the cost of a hamburger and what is the cost of a bag of fries? So the first thing you need to remember, we talked about this before. I know it's been a while, but typically, not 100% of the time, but probably like 99.9% of the time, the questions that they ask are what you're going to make your variables. So, and there's 2 questions, so that means there's going to be 2 variables in this one. And that's definitely not 100% of the time, but in this case, it will be 2 different variables. And if you know it's a problem about a system of equations, then you know you're going to have more than one variable anyway. So what we're going to do is we're going to say, all right, well, let's make, I'm just going to use, actually, I won't use X and Y. Let's use H for hamburgers. Oop, click on that. H for hamburgers, and we'll use F for fries. So what are they asking? Or you could also think, what do we know? Well, I know how many they bought. And typically, especially when you're dealing with a money problem, your only 2 options are the variable is either going to be how many, like what is the quantity of the item, or it's going to be what is the price of the item. That's pretty standard. Again, not 100% of the time, but if you just remember that, you'll get a lot of questions right. Well, we already know how many, what the quantity of hamburgers and the quantity of fries is. So if we already know how many, that can't be the variable. So the variable would probably be how much do they cost? And sure enough, if we look at the question, it says how much does 1 hamburger cost? How much does 1 bag of fries cost? So this is going to be the cost of 1 hamburger. And then fries would be the cost of 1 bag of fries. Pretty standard. Again, not 100% of the time, but if you stick with this, if you just learn this one thing, that the variable is normally going to stand for whatever the question is asking. And then also, if you already know the information, like we already know how many, then that means the variable must stand for how much. That's pretty common in money problems. So the cost of 1 bag of fries. All right, so we know that. That's what our variables stand for. We're set there. So now, again, if we have 2 variables, we need 2 equations in order to be able to solve for the variables. That's the only way we can do it. 2 equations, I'm sorry, 2 variables, 1 equation, we can't solve that. So let's look at what we've got. We've got 2 people buying food, and then we've got a total cost of what their food is. So let's think about that. Well, we've talked about what y, or what the end of the equation normally stands for, and the total is normally at the end. So I'm going to kind of write it backwards, but this is going to be my total for Edwin. Actually, I'm going to do Edwin's in red. So there. So Edwin's total amount is $31.50, and that is typically going to be the end of the equation. So how do we get to that $30.50? Well, that's the amount he pays for hamburgers, total amount, I put total. So the total dollars he pays for the hamburgers plus, kind of the same thing, the total dollars he pays for fries. Right? That's going to be his total cost. Total money, or grand total, is sometimes what you may hear. So that's my equation in words. I always encourage you to write it out in words. I encourage you to draw pictures. This is kind of the same thing as drawing the pictures. I'm not dealing with variables or anything. So now I kind of have an idea of where this is coming from. So now I can break it down even further. All right, well, what is the total cost of my hamburgers? Well, that's not too difficult. That's just how many hamburgers. So it's how many hamburgers I'm not really going to do anything on the left, but I'm going to keep it over there. How many hamburgers and then times, so that means times right there, the price per one hamburger. Price per one hamburger. I'm going to have to start abbreviating that so I don't run out of room. And then we would take that and we would add it to the total cost of the fries. Well, the total cost of the fries is really just kind of the same thing. It's how many bags of fries bags of fries, and then times the dollars, or the cost per one bag of fries. So again, in words, that's my equation. $31.50, which is the total dollars spent, so it's still total dollars. Total dollars is going to be how much did I spend on just hamburgers, and then how much did I spend on fries. Well, now I can kind of start filling some of this in. So 31, oops, don't know what happened there. Try that again. I should put this in tablet mode. That would probably work better, but I'm afraid it might mess it up, so I'm going to avoid that for now. So 31.50 equals, I know how many hamburgers, again, I'm doing this for Edwin. Edwin bought 3 hamburgers, so that's how many hamburgers he bought. I don't know how much one hamburger is, but I do know that the cost of one hamburger is H. I made that my variable up top right here. So if I know that's what, then I can just put 3H. So then, oh, it's not times, then we would add that to the total. Oh, I messed up. I don't know if you caught that. This should have been fries. Oh, wait, nope, I take that back. Shouldn't have been fries. So again, I'm going to circle this so it's a little clearer. So this right here, how many hamburgers, is represented by that 3. The cost per hamburger, so the cost per hamburger is represented by that H, and we showed that again up top. We said, well, the cost of one hamburger is H. Now I'm adding to that And here's the next part. How many bags of fries? Well, the bags of fries, I'll actually, I guess I'll go back to red. So the bags of fries, I think was 4. Yep, Edwin bought 4 bags of fries. And then the cost per bag of fries, well, we don't know that, but we did say that F is the cost of a bag of fries. So it would be 4 times F. So that's my equation. 31.50 equals 3 times H plus 4 times F. Don't get freaked out just because I'm using H and F. That could have been X and Y. So now, kind of the same thing. I'm not going to go through the whole process. Now we look at Selena. So Selena bought 5 hamburgers, 2 bags of fries. Her total cost was 35. So if her total cost was 30, I don't know why it does that. It drives me crazy. Her total cost was $35. She bought 5 hamburgers, so the concept is the same, and then 2 fries. Oh, I meant to do this. So that blue matches up with that. So the 4 is the how many bags of fries, and I guess I'll use purple. So the cost per 1 bag of fry is that variable right there. So now that kind of is all matching up. Whatever I circled matches up in the equation down below. I can do that again with these. So that's how many hamburgers Selena bought. That's how much 1 hamburger is. Doesn't really change per equation. I'll talk about that in a second. That, and then last but not least, that's the cost of 1 bag of fries. So I didn't really mention this before, but it should be fairly obvious that the cost of a hamburger is going to be the same for Selena or for Edwin. And that's critical. The cost has to be the same or you'd never be able to solve this out. So that's why we can use H in both equations, because it's going to be the same number. Whatever 1 hamburger costs for Edwin, it's going to cost the same for Selena. We're assuming they're buying them from the same exact place. Same way with a bag of fries. Whatever Edwin pays for the bag of fries, Selena is paying for the bag of fries. If it wasn't the same price, then we wouldn't be able to solve this out. We would technically have 4 different variables because they'd be paying a different price for each item. But in this case, they're paying the same price. So H is the same in both equations. Whatever that, we don't know the value of it yet, but it's the same, whatever it is. And then the cost of the fries is the same in both equations. So this is actually one that is a lot easier to solve with elimination. So I'm not even going to do the solution, and I'm not going to make you do the solution. We're not going to graph it. All you have to do is be able to set up the equations. So that's what we're going to do this week. You're going to have an assignment where you have to do a few of these, create the equations. You will not have to solve them out though, so it should be pretty easy. I'm going to do another one real quick. Here's another one down here. Company A costs an initial setup fee of $40 and then $3 per poster. Company B charges an initial cost of $15 and then $8 per poster. This one's a little bit different. It's a little bit different because both of these equations are actually going to be in the format of y equals mx plus b. So they're both going to be in that format. And the reason I know that is because I see this number that is an initial fee. Remember, whenever I see that initial setup cost or deposit or something like that, that tells me, actually, I'll just keep it in black. That tells me that I'm going to have a y-intercept. Because remember how we talked about the y-intercept is like the initial cost or the setup cost or the deposit. So that's how I know they're going to be in that format. Pretty much that you can, plus I also know this, there is a per in there, per and then per. So that's kind of telling me rate of change. Although if you'll notice, we also had that up here where they talked about, well, here we talked about, in the question, they said, how much does 1 bag of fries cost? How much does 1 hamburger cost? That's kind of the rate of change also, but there was no initial value. There was no one-time amount. So that's why those didn't come out to be in y equals mx plus b. So that's what you're looking for to know how to set them up. Again, you'll just have to work through some of these and it'll become more natural and you'll know when to set it up one way and when to set it up the other way. So now, all right, what would be? So this end of the equation right here is going to be whatever the total amount is. Well, I see company A charges $40. So I'm going to start with that. That's going to be at the end of my equation, and that 40 is going to come from some combination of things. Well, what's the combination? So that's my total again. Wait, I'm sorry, that's wrong. That's totally wrong. What was I thinking? So the total we don't actually know, because the $40 is an initial fee. That's a one-time fee, and then it's $3 per poster. So the total we don't know. So again, sometimes you got to think through these, even I do. So there's a Y. We don't know the total, so that's going to be the Y. We know the initial cost, which is that, and then we know the cost per poster, but we don't know what the total cost is. So Y is going to equal, again, the initial cost is going to kind of be at the end, because that's the one time. And then the per poster cost, the $3, is going to be our M value, and then there's our X. So these are actually pretty easy to set up once you figure them out, once you figure out which direction you have to go in to do it. And then same thing down here, Y equals, total is going to be for company B, so this is company A, and then down here, this is going to be company B. So same thing, the total for company B is the initial cost. They have a lower initial cost, but then they charge, I'm gonna have to delete or erase some of this, get rid of all of that. They charge $8 per poster. So I need to do $8 per poster for them then. $8 per poster. So my variable Y stands for the total cost. My variable X in this case is going to be the number of posters. And the way I know that is from this statement right here. If it's $8 per poster, the last word in that statement is what X is going to stand for, the number of posters. Same way up here. The last word in that statement is what X stands for. And again, if I read the question, it's asking me what, get rid of all of that so we can read the question. What would the cost of posters be? So that also is kind of a hint. But mainly you look at the statement where the word per is. So you look at this statement and you look at this statement and you take the last word in that statement, whatever follows per or each or whatever the key word is. All right, so now these you can solve out. So I do want you to solve out these, and I'll tell you when to do that. If you need to solve it out, I'll tell you to solve it out. If you're not going to solve it out, I'll tell you to just write the equations. But we could do this a couple of ways. You could graph it, and if you graphed it, you would see where they hit, although I will tell you it would come up with a decimal, and so you wouldn't really be able to get an exact number if you graphed it. So I'm going to use substitution to solve it out. I'm going to zoom out a little bit too so that we can fit more of this on the screen. Extend it a little more. There we go. So scroll up. There. All right. So if I know that Y is equal to, so right here, I'm looking right here, I know that Y is equal to this. using that concept we talked about, a dollar bill is the same thing as 4 quarters. Well, I could look down in this equation down here, and I could say, okay, well, instead of this variable y, I'm going to plug in that 3x plus 40, because they're the same thing. I could either have y right here, or, which would be like having a dollar bill there, or I could take the 3x plus 40 and put it there instead, which would be like replacing it with 4 quarters. So I'm going to rewrite this equation as 3x plus 40, because I'm replacing this y right there. And that's still just going to equal 8x plus 15. Nothing changes over there. So now I can solve this out. You should be able to solve this out. I'm going to move my x values. This is not the way I taught you originally, but I kind of changed it, and we're just moving all the variables to the left. So to move the variables to the left, oops, I'm not going to do that yet. I need to subtract 8x to get rid of it. Well, if I subtract it there, I need to subtract it here. So that gives me negative 5x plus 40 equals 15, because this canceled out. So now, I have to hopefully, we'll do it this way. There, we'll do it one time. So now I need to say, okay, well, if I want to get this x all by itself, right here, I need to get rid of this. So I need to move all my numbers basically to the right. Oh, again, I don't need to do that. So if I subtract 40 there, I subtract 40 here. Oh, you know, one thing I didn't do, and I'm going to do that. Let's draw our line down the middle. Boy, oh boy, oh boy, it drives me crazy when I do it. Oh boy, I did it again. Not sure why. Oh, what in the world is going on? All right, we're gonna just move that line since it, for some reason, wants to keep drawing another line. All right, so whatever I do on the left side, so this subtract 40, I need to do on the right side. So that's going to give me negative 25 on the right equals negative 5x on the left. All right. Oh, yeah. So now I could say, all right, well, I divide by negative 5. What is wrong with this stupid drawing tool? Divide by negative 5. Divide by negative 5. Good thing Mr. Gill doesn't use profanity, else he would be doing it. And so that means x equals 5. So if I go back up, it'll tell me I already kind of created. X is the number of posters. So that means at 5 posters, the cost of either company is going to be the same. So it doesn't matter. If I want to buy 5 posters, it doesn't matter which company I use. The cost, the total cost to me is going to be the same at that number of posters, which is basically what I set up when I said, we'll use blue. When I said this equation right here equals this equation, those equations represent the total cost of each company, and I want them to be equal. At what number of posters are they going to be equal? Well, I just solved it out, and it told me at 5 posters, they're going to be equal. So I kind of need to change this a little bit. No, I don't. That's right. So when those two companies have the same total cost, that solves out to be 5 posters. We could check that. We could do the math and plug 5 in. So if I plug 5 in to the top equation up here for company A, I plug 5 in right here. Well, that means 5 times 3 is 15. 15 plus 40 is $65. So 5 posters cost me $65 for company A. Well, how many does 5 cost me for company B? So now I'm doing it down here. Well, 5 times 8 is 40 plus 15 is, I'm sorry, I did the math wrong. It's $55, not $65 for both of them. So I know that's a little confusing. I'll probably do another video with another problem similar to this one. I think I already have some on YouTube as well, word problems that are linear system of equations. That's all I'm going to do for this video, though.